Hi friends, welcome back to the channel. It's Given here from Techno Drive. In today's video I'm going to show you how we can repair this mast inverter. We've got a mast inverter on the table. So this inverter has got an error 9. So this inverter is coming from Mozambique. You can see the label here, it's written in Portuguese, so it's coming from Mozambique. So we are going to try and fix this inverter, and then we can test it and make sure that everything is alright. So what's the problem? This inverter has got error 9. So right now I'm going to open it up, but before I open it, let's switch it on and see what's happening. Okay, you can see it's coming on. You can see the voltage 52 volts. There it throws a red light and it's error 9. Let me try and zoom it in so that you can see what error we are having here. You can see there it's error 9. So we are having error 9. The voltage is okay, 52.4, but we are having error 9. So I'm going to open the inverter so that we can see why are we getting that error 9. Then eventually we can repair this inverter. But when I look on this inverter, we have to first clean it because it's too much dirty. If you look here, you can see that there's too much dust here. So this inverter needs to be cleaned before we can actually do the repairs. So I'm going to take it outside, blow it, take out the board, then we can continue with the repairs. Okay, I've just opened the inverter. Before I can take it out for cleaning, you can see the condition here. So this inverter is dirty. We need to clean it. If you look, there's too much dust there. We need to clean this inverter thoroughly because dust it's also not good for the inverter. It also blocks the cooling and can affect the performance of the inverter. So we are going to clean it, then we can come back, because obviously we cannot clean right inside the workshop. We have to go outside and clean it. Okay, I've now cleaned the board. It's not at 100%, but we can work on it. Yeah, I've removed the board from the covers, and also I've removed the LCD. You can see this is the LCD for the display, and also the fans. So I've got the fans out so that we can test the inverter. Let's see if it does the same thing when it's out. Okay, I'm gonna switch it on. So you remember we took out the switch. So this connection here is for the switch, this one here. So we have to put the bridge piece so that the inverter can come on. There, the inverter is coming on. There we already have got an error 08. So it's giving error 08 because there's no MPPT charger. So we've disconnected the charger. So we need to connect the charger so that, because you can see the PV is showing 600 volts. That's wrong. That's why we are getting error 8. So we can't test the board without the MPPT charger. Let's connect the charger. Okay, here's the MPPT charger. So we don't have to connect it on the board direct, but the only connection that we have to do, it's this one. So it's this cable. So this cable is the one that measures the voltage that's coming from the solar panels. These other ones, we can leave them disconnected. That's why we are getting error 8. Let's just connect this. I've connected, and also we're going to connect on the control board. Okay, we've got it connected. Let's see what's happening. I'm gonna switch on again. It's not easy to see, but you can see 09 there. Let's try and zoom in. You can see 09. We are having error 09. Okay. Okay, now we can work on this board. So, like I've mentioned already, what is error 09? Error 09 is caused by the low voltage on the DC bus. Remember, here we should have like 400 volts on these 2 points. So these two large capacitors are called the DC bus. If you look at the MPPT, you see this MPPT, it connects, one point connects here on one terminal for the DC bus, and the other point, which is going to be bus, let me show you. You can see there's bus plus there and bus minus. So that's our DC bus. So error 9, it's caused by low voltage on those 2 points. So if we don't have enough voltage on the DC bus rail, we're gonna have the error 9. So what we are going to do is to switch on the inverter, connect the multimeter on the two DC bus terminals, and see what voltage we are getting. Let's do that. Okay, let me get our meter ready. Okay, there we've got our multimeter. It's on a DC. Let's connect on these 2 points and see whether we are getting enough voltage. You can see we are having 27 volts, 26 volts, and it's going down. So let's switch on the inverter and see. Okay, we are sitting at 22 volts. The inverter is on, and we already have got error 9. You can see that the voltage is not going higher than 300 volts, because we need at least plus minus 300 volts to 400 volts on the DC bus. We are getting error 9 with no changes on the DC bus, sitting at around 20 volts. So let's check what's causing that. So I'm gonna flip the board, then we can measure all of the IGBTs, MOSFETs, to see if they are not causing any error. Okay, let's start with the IGBTs. Check the output IGBTs, the charging IGBTs. and all of the MOSFETs. Let's take our meter to the diode mode. Okay, let's check all of the IGBTs. Okay, we're gonna put our meter on diode mode. Let's see the volt drop on all of the MOSFET. We're gonna check between the collector and the emitter. So these 2 points, this is our emitter, this is our collector, and this is the gate. This is the pin that drives the IGBTs. So this is the pin that drives this IGBT, this one drives this IGBT, this one, and so on. You can see this one 0.4, 0.4, 0.4, 0.4, 0.4, 0.3, it's okay, 0.4, 0.4 volts, 0.4, and the last one 0.4. So all of these IGBTs, they are reading okay. So what could be wrong? Let's check between the 2 points, but I don't think there's a short, because remember we're getting 20 volts, so obviously there's no short circuit there. But I'm gonna check the resistance in any way. Just check, but you can see there's no short circuit. You can see if there's a short, the meter will buzz. There's no short on the DC bus. So what could be wrong is the soft start circuit. See, this circuit here is the one that pre-charges the capacitors before the MOSFETs can charge the capacitor. So I'm 99% sure the problem is on the pre-charge circuit. Let's check the diode for the pre-charge. Okay, this is the voltage that's there, but there's no short on the diode. Let's check this MOSFET. Remember this pre-charge circuit, it's this circuit here. See, this circuit is the one that charges the capacitors before the MOSFET can come in. So the capacitors needs to be pre-charged to avoid inrush current. So I'm going to check this MOSFET because it's the one that switches this transformer. So this MOSFET, it gets the 48 volts that's coming from the battery. Then it will switch at a high frequency. And then we're going to end up having high voltage on the DC bus. So let's look at that circuit. Let's see if there's no problem on that circuit. Okay, this is our pre-charge circuit. So that is the transformer pins here. This is that MOSFET, and this is the diode. Okay, and let's check if the windings are okay. Okay, you can see we've got a short. It's basically not a short, but it shows us that the windings are okay. Let's check the windings for the low voltage. So the windings are also okay here. So these 2 points are for the windings for the primary, and these 2 points are the windings for the secondary. So we are having a connection here, so the transformer is not a problem. So let's check these resistors. So these resistors, let's check the value. So these resistors are 22 ohms each, and they are connected in parallel. So I'm going to take our multimeter to the ohms mode. So if they are connected in parallel, we're going to have 22, then we're going to divide them. So it's going to be 11 ohms. If it's 2, divide by 2. There you can see we are having 11 ohms there, because they are connected in parallel. So that's okay. So now let's check the shunt resistor. So this one is a shunt resistor that connects to the MOSFET. Let's check. We are having a good reading. Let's check between them. Let's check between the emitter and let's check with the diode mode. I'm going to check the MOSFET. So this is the voltage, it's not yet reading 0.5. So the MOSFET is okay. Let's see what else could be the problem. Okay, let's now check if we get the voltage on the MOSFET. These 3 pins between the source and the drain. Let's check if we do get the voltage. We need the battery voltage here so that the pre-charge can convert that low voltage to high voltage. Let's connect power again. Let's measure here. Okay, we've got a DC voltage here. We've got the battery voltage. Okay, we've checked the voltage that's coming to the MOSFET. You saw we've got 51 volts here. So it means that the switching is not being activated. So what we're gonna do, because this switch mode power supply, to change it, to convert 51 volts to 400 volts to pre-charge the capacitors, it's controlled by this optocoupler. So we're gonna put a bridge piece here just to activate it. But remember, this is very dangerous. If we connect the bridge piece continuously, it's gonna go to more than 400 volts. The voltage will, because it's no longer controlled. We are just testing to see if this IC, so this is the IC that controls this MOSFET. So we are going to check if this IC, is it working when we switch on the optocoupler manually. Then if it works, it means that the optocoupler is not being switched properly. That's why we are not having the startup voltage, and that's why we are having error 9. Okay, I'm gonna put my meter here. On the positive lead. and the negative. Okay, you can see we've got 0.7 volts. Let's switch on the inverter, and then we can see if the problem it's on the IC or the switching side. And there it's coming on. You can see we've got 0 volts, 0.7. The voltage is not going up. It should have been up already. So let's connect the bridge piece on the optocoupler, then we can see if the voltage goes up. Okay, there's our optocoupler. Let's take a look there. You saw there, now it's 60 volts. Let's connect again. You can see 170 is charging, so it's charging okay. So you see we've got 300 volts there. So this is our DC bus. So if we short here, it's going up, but we can't keep on shorting because it's gonna go over voltage. You can see we are now at 400 volts. So it means that the problem is on the control of this optocoupler. So this optocoupler is not being switched properly, then it's not activating the IC to switch on the MOSFET, and then we can have the DC bus. So we're gonna have to trace and see why are we not getting the control signals. Okay, for us to work better, remember this 200 volts, it's a high voltage. We have to discharge the voltage. You can use the resistors to discharge. Let's connect. You can see now we've got 0 volts. You can just discharge it, because if you work with high voltage, there's a risk of shocking ourselves and also damaging the board. So I've discharged it. We're gonna continue checking why is the problem, where is the problem. Okay, so far we have seen that when we activate this optocoupler, we do get the DC bus voltage here. So which means our startup circuit is okay. Why is it not being switched on? So remember this optocoupler, it has got this resistor here. Let's zoom it in. Okay, I've zoomed in now. So there's this resistor here. So this resistor, we should get a voltage here, which is around 12 volts, so that it can switch on the optocoupler. And this voltage, it's coming from the IC that controls the DC to DC. So let's zoom out, then we can see properly. So that resistor, that small one there, it goes right down to the IC. There's an IC here. See here. There's an IC that controls the startup. Check here. Okay. So let's check if there's a continuity between that resistor and it's pin 4 of the IC. Let's check with the continuity. So I'm checking all the pins of the IC. There's nothing. Okay, so let's trace and see where is this pin going. You can see it's going down there. Maybe the track is okay. I'm checking these tracks here. So you go, okay, it's going here. And then it comes here. Okay, I'm trying to make sure that we see what's happening here. So one pin here of that resistor that goes to the optocoupler, it's coming to one of the tracks here. Okay, it looks like it's not coming there. Oh yeah, yes, it's coming there. And then it goes forward. There's a current sensor here. So it means that this is a supply. It's a supply. This is a supply for the current sensor as well. It also supplies the optocoupler. But where does it get the power? It gets the power on this side here. So we need to make sure that the power is coming there. You can see I've got nothing here. When I check on the IC, there's no continuity. So you remember it's coming to here, pin 2 of the current sensor. There's nothing here. There's nothing. So which means there's no power between here, which is the supply. The supply is here, and the optocoupler or the current sensor and the optocoupler doesn't have anything, but they are connected. Let's check with the other board. Okay, I've got another board here. Let's check. There is the resistor. It goes to the second pin of the current sensor. Fine. Then the second pin of the current sensor must go to one of the pins on the drive IC. There. See this one, there's a continuity here. So it must come to pin number 1, 2, 3, 4, pin 4, which means there's a broken track. It's unbelievable. It's unbelievable. Let's see. It's on pin number 4 here on the drive IC. Pin number 4. Okay, you can see this is our drive IC. So this is the broken board. So pin 4, 1, 2, 3, 4. So this is the pin that has to be connected with pin 2 of the current sensor and the optocoupler. You can see the current sensor there. I'm holding pin 2. You see there's nothing. There's no connection. So let's check where else that the resistor goes. There is our optocoupler. this is the other point of the resistor. Let's check all of the tracks. We've got some other tracks right on the other side. It could be that the tracks are going to the other side. So you can see we've got some tracks there. So these tracks are going down to get power as well. So let's check if this resistor doesn't connect with one of the tracks here. Yes, there's one. Let's try to scratch there. It means that this is our supply rail. So you see this, yeah. Let's zoom in, then we can see, follow that track and see how we can sort it out. So this is our problem track. Let's connect that resistor there. Let's check which track. So this is the track. Let me scratch it. So this is the track that supplies the optocoupler. We're gonna check why is it not reaching the IC right at the bottom. Okay, I've scratched it. Let's zoom in. Okay, there is the track. Let's follow it. There it goes. What is this white thing? Yeah, this board is corroded. You can see this track is not green, and here there's a white stuff here. Let's zoom a little bit in and see what is that white thing. Could be our problem. See those white stuff. They could have eaten that track. Okay, let's check between there and here. Okay, we do have a continuity, and there and here. Wow, unbelievable. See, when I scratch here, there's nothing, and here, so we've got the broken track here. And this white stuff, it's a lot of them. You see here also. So they've eaten the track. Okay, we're gonna have to repair this track and see what it how it goes. Okay, let's repair the track. Okay, let's clean the track. Let's clean all of the tracks. clean the tracks, you can see this track that one is broken. So we're gonna we'll add some flux, and just the other ones are okay. Okay, put some flux there. We are going to coat them again, but we're just making sure that there is a proper contact with the solder. We don't want loose connection again, so just joining all of them. Let's add a bit of flux again. Okay, all of the tracks looks okay, but we still have to join that one, because that one was broken. So we're gonna use this wire to make a new trace. This is the trace that was broken. Okay. Let's cut the excess. Okay. Now we've got the connection. Let's check again with the multimeter to see if we are getting a reading. The meter is ready. Let's check one pin goes to the second pin of the, there it goes, and it goes to pin number 4 as far as I remember of the drive IC. 2, 3. Let's check. There we go. You can see there we now have a connection. Even when I connect between pin 2 here and pin 4, we've got a connection. So where was the problem? The problem was on the track there. So we fixed the track. We're gonna coat it, but let's test it. Do you think it's fixed? I'm not sure. Let's test it together and see what is the outcome. Okay, we've repaired the tracks there. I've now connected the probes on the DC bus. Let's switch on the inverter and see if we do have the DC bus now. We are sitting at 12 volts. there we've got the DC bus 300, 360. Whoosh, then it drops. But now we got a progress. We are now sitting with error 8. So we've got error 8. I've got the charger connected. But we are having error 8. Okay. Let's check the voltages. I'm going to check on the optocoupler there, because as far as I remember we should get the 12 volts. There we go, we've got 12 volts that's coming to the other pin of the optocoupler. So the trace that was damaged is now repaired. You can see this is the trace. We've got 12 volts there. Okay. And also this trace is going to the second pin of the current sensor. We've got 12 there. So we do have voltages, but we are sitting with error 8. Let's see what's causing error 8 now. Yeah, today is another day. We are going to continue with this inverter. So you remember we're having error 08. So what is error 8? We are going to continue from there. You remember we sorted out the error 9. Initially it was error 9. It's now fixed, but we are still sitting with error 8. You can see there, error 8. So what is error 8? Let's look at the manual. The manual will tell us everything. What is error 8? So you can see there on the manual that error 8, it's caused by inverter bus voltage too high. So if the inverter bus voltage is too high, the inverter will give you that error 8. But our DC bus, it's not high. So it means that the inverter is giving us a wrong alarm. So let's measure the DC bus. So this is our DC bus. You can see that we've got 320 volts. So let's restart the inverter and see how far it goes. Okay. So normally the inverter, when it's running, we should get 390 volts. So if it's more than like 400 volts, the inverter will give you error 8. You see we've got 380 max. So it means that the inverter is giving us a wrong information, because we've got 360 volts, 380 volts maximum. That should be okay. So what could cause that? This is simple. This could be caused by these resistors here. If you look at the connection, these resistors, all of them, they go to the DC bus. You see there? They go to they go to the DC bus. Then this is the output. These 2 points are the output that goes to the CPU. So obviously we need to check the voltage that's coming out from here on the DC bus to the microcontroller. So what is the formula to calculate the voltage that we should get on these 2 points here? So from our calculation before, and from the working inverter, we saw that the formula, it's the voltage divided by 390, divided by 200, I mean. You see, if we have 390 volts, if we divide it by 200, it gives us 1.95 volts. So we should get 1.95 if the inverter is at 390 volts. So we divide the voltage by 200. So we should get the output voltage here. So let's measure here and see if indeed we are getting a correct voltage. So I'm gonna measure on the output here. Wow, you can see we've got 2.7 volts and we are sitting at what? 350. So which means these resistors are no longer alright. They are no longer doing their work. You see, 2.5. So we should get at least 1.9 when we are at 390. So we are at 320 something volts, but already is 2.5. So we're gonna change these resistors and see what happens. This 0 ohm we can leave it, but these ones we need to change them. Let's change these resistors and see what happens. Okay, I've got the hot air station ready with me. We're gonna remove these resistors. So we can leave the 0 ohms, they won't make any difference. Okay, we've now replaced the resistors. Let's check the resistance. That looks okay, yeah? 1 mega ohm. 1 mega ohm. This one. Yeah, 1 mega ohm. Okay, we have replaced the resistors. Those are the resistors there that measures the DC bus. So these two last resistors, they go to the CPU. So let's measure and see what's happening now. You remember we're getting more than 2 volts, which is not right. So these are the points. So let's switch on the inverter and see what we are getting. Okay, when the DC bus starts, the voltage will go, but it shouldn't be more than 2 volts. Yeah, you can see we've got 1.9 volts. The connection is not proper here. Yeah, there, 1.9 volts. So this is what we should get. You can see the inverter is already giving an output, 229. So the inverter is okay now. No more 08. You can see on the screen, no more 08. We are having 1.9 there. You can see the frequency, 50 Hertz. We are good. We are good. You can see when I measure, Okay, when I measure here, you see now we are on AC. There is our AC. When we measure on these 2 points, this is our output. You can see we've got 226 volts. So the inverter is running now. This is the output that's coming from the inverter. That's good. You remember we fixed the track there. I'm going to code it now. Resistors sorted, and the inverter is running. Got 220 there. So that's how we fix the problems like this. So if you've got an inverter like this and it's giving you some problems, you can phone us. You can see our number there. You can send the inverter anywhere in South Africa. If you are battling, we will help you. So this inverter, like I said initially, it's coming from Mozambique. So we are done with the job. I'm going to put back everything, then we can send the inverter to the customer. So that's the job for today. We are done with it. Thank you very much, and thank you for watching. Hope to see you on the next video. Keep well.